Hi everyone, welcome to our project presentation where Team CaptionMe. So image caption is the multimodal problem that has been extensively researched in both natural language processing and computer vision. It's a complete sentence that describes the picture. They are important since they spark a reader's interest in a full-text story and context vision and language in a generative fashion. Our team designed and implemented an image caption model that can generate captions in given a doc image. So our group obtained all source image from a Kaggle data set. It contains stock images for 70 different breeds, and we manually selected 16 images for each dog breed and created 4 captions for each image as a ground truth label. One of the captions must at least contain the actions of the dog. The rest of them contain more information such as the dog's breeds and colors and the environment of the image. Next, please. And then we split all samples into 80% for training and 20% for validation. And the data augmentation is also applied to generate more training samples so that our model will have a better generalization ability, such as the random horizontal flip, random rotation, and color jitters. One issue with our data is that the glove and bird tokenizers fail to recognize some dog breeds. To solve this, we replace the name of those dog breeds with similar words in our vocabulary through the dictionary, and then we applied another dictionary to reverse those changes during generation process. And since dogs of the same breed can dramatically differ in color and shape, our model can achieve a low loss even with a missing or incorrect dog breed. And it's a challenge for our model to correctly give the dog breed in the generated caption. Next one, please. Our baseline model is composed of a CNN-based encoder and a transformer-based decoder, and we fine-tuned the pre-trained MobileNet V2 and replaced the original classifier with 2 fully connected layers, one activation function and one dropout layer to generate the visual factor. And the transformer-based decoder has an architecture similar to GPT Mini in Assembly 3 with the embedding size of 100. And when configured the optimizer, we apply the CNN-based encoder and the transformer-based decoder with the learning rate of 3E-5 and 3E-4 respectively.
As introduced in our proposal, our anticipated model is built based on the CPTR. However, some changes has been made in our final design. In the encoder, instead of dividing the input image into the patches with the same size and feeding into a linear embedding layer, we replaced this procedure with a backbone network. Specifically, we fed the input image into a pre-trained resident 101, and we extract the feature map in its intermediate layers. And we reduce this feature map size by a projection layer with a kernel size of 1. And in the decoder, we use cross-attention transform block to combine the visual and the semantic information. And similar to the self-attention transformer blocks, we use the query, key, and value vectors to get a better encoding of the source and target words. And in the cross-attention transformer block, we apply the generated sequence of text as the query input and the output from the encoder as the key and value inputs. We use the blue score to compare the model-generated caption with 4 reference ground truth captions. And in our qualitative test, we select 2 images from the test data set and use each model to generate 4 captions for each image. Then we apply the top K sampling method with K equal to 3 to recursively generate words for the captions and compute their quality using the blue score. As you can see in the images, the baseline model successfully generated complete sentences for the captions. However, it did a bad job on describing the image details, including the breed, actions, background, and color. And anticipated model performs excellently on both images. And also, you can see like most of its generated captions are correct and informative. And also the blue score for the anticipated model is much higher than the baseline model. And in our quantitative test, we apply the same approach in the qualitative test, but on all the images in the test data set. And the average blue score is computed. And you can see in terms of the average blue score, the anticipated model outperforms the baseline model very much. As you can see in these 2 images, the validation and the training loss curves for the baseline and the anticipated model follows the similar trend. And in the baseline model, the loss decreased dramatically in the first 3 epochs, but the performance started improving in the following epochs. And for the anticipated model, the validation loss decreased in the first 4 epochs significantly, and its performance still continuously improving in the rest of the epochs. And the anticipated model indicates a great potential on generating high-quality captions. And in the future, in a similar project, we would explore more on this model architecture by generating more captions for images, including but not limited to dogs. Okay, thank you.